So 900,000 people installed a browser extension to help them use ChatGPT, and it was silently uploading every single conversation they had to an attacker's server. Not some sketchy sideload. The Chrome Web Store and some agentic browsers, they installed it automatically.
Context Window. Your weekly window into everything. AI security.
Welcome to Context Window, your weekly window into everything worth knowing in AI security. Quick thing before we start, full transparency. This podcast is AI generated, 2 AI voices, a script written by another AI agent, the whole thing. But every story, every take, every here's what this actually means is curated and verified by Asaf Nakash. He builds AI security products at one of the world's largest security platforms. So yes, the robots do the talking, but a human who lives this stuff makes sure we're not hallucinating.
We're literally an AI podcast covering browser extensions that steal AI conversations. If we start recommending you install unverified Chrome plugins, definitely let Asaf know.
This week, we're going deep on those malicious AI assistant extensions because the scope is worse than the headline suggests. Then we've got a CVSS 9.8 in an AI agent framework with no patch, Windows Notepad, yes, Notepad, becoming an attack vector, and a wild M&A week where 3 major vendors made moves, plus Curator's Corner on why agent memory needs its own zero trust moment.
Wait, Notepad? Like the text editor I use to write grocery lists? That Notepad?
That exact Notepad. We'll get there. Okay, let's start with the big one. Security researchers found a cluster of fake AI assistant browser extensions in the Chrome Web Store. These were impersonating tools for ChatGPT and DeepSeek, the 2 AI chatbots everyone and their manager is using right now. And collectively, these extensions had been installed roughly 900,000 times. They were detected across more than 20,000 enterprise tenants.
So to be clear, these weren't janky, misspelled extensions that look obviously fake. These were polished enough to pass the Chrome Web Store's review process. They looked like a legitimate productivity tools.
Exactly, and here's what they were actually doing. Once installed, they silently collected your full chat history with the AI assistant. Every prompt you typed, every response you got back. Browsing data too. Then they exfiltrated everything over HTTPS post requests to attacker-controlled domains. So from a network monitoring perspective, it just looks like normal encrypted web traffic.
Think about what's in those chat histories for a second. People paste code snippets, internal documents, customer data, strategy memos. You know, people paste entire database schemas into ChatGPT and ask it to optimize their queries. That's not just browsing data. That's the keys to the kingdom.
And here's the part that really got my attention. Some agentic browsers, so browsers that have AI agent capabilities built in, the kind that can take actions on your behalf, they automatically downloaded these extensions without explicit user approval. The extension just showed up.
That's a fundamentally different threat model. We're not talking about a user being tricked into clicking install. We're talking about an AI agent deciding on the user's behalf that this extension looked useful and installing it. The human never made a choice.
Right. And there's another detail. Telemetry re-enabled itself after updates. So even if a user went into settings and turned off data collection, the next extension update silently turned it back on. Persistent surveillance masquerading as a toggle.
So the opt-out was theater. You click disable telemetry, you feel safe, and then the next silent update undoes your choice. That's not a bug. That's a design decision by the attacker.
Yeah, the broader issue here, and this is what makes this more than just a malware story, is the trust model of browser extension ecosystems. We've spent years building sandboxes for mobile apps, vetting app stores, requiring permissions, disclosures. Browser extensions still operate in this weird gray zone where the review process is automated. Permissions are broad, and most users just click Add to Chrome without thinking twice.
And now those extensions sit between you and your AI assistant. They can see everything. It's not like a keylogger that captures keystrokes. It captures the full context of your interaction with an AI that you're probably treating as a trusted advisor.
So if you're running an enterprise environment, here's the takeaway. You need an extension allow list. You need to be monitoring what extensions are installed across your fleet, especially the AI-related ones that have popped up in the last year. And if you're evaluating agentic browsers, i.e. browsers with AI agent capabilities like Curated, you need to ask hard questions about what those agents can install without human approval. Because right now, the answer at some vendors is pretty much anything.
And honestly, even for individual users, go check your browser extensions right now. If you installed some ChatGPT helper 6 months ago and forgot about it, it might be worth verifying who actually made it.
All right, let's shift gears. Speed round time. First up, CVE 2026-2256, a command injection vulnerability in ModelScope's MS agent framework. This one got a CVSS 9.8, which is about as critical as it gets. MS Agent is an open source framework for building AI agents. Nothing to do with Microsoft, by the way. It's by ModelScope, and it has a shell tool, basically a way for the agent to execute system commands. The security boundary, a regex-based deny list, a list of commands the agent isn't supposed to run.
Oh no.
Yeah. Attackers figured out you can bypass it trivially through prompt injection, and then the agent just runs arbitrary OS commands for you. Public proof of concept is already out there.
A regex deny list as your security boundary for shell execution. That's like putting a screen door on a submarine, and there's no patch yet. If you're running MS Agent in any production environment, you need to sandbox it immediately. Don't wait for the fix.
Next, and Nina. This one's the Notepad story I promised. CVE 2026-28401, CVSS 8.8. The modern Microsoft Store version of Notepad added markdown rendering, so it can display formatted text, clickable links, that sort of thing. Turns out it wasn't sanitizing protocol handlers in those rendered links. You open a crafted markdown file, click what looks like a normal link, and boom, remote code execution.
This is the one that went viral as Death by Notepad. And honestly, it deserved to go viral because it's the perfect illustration of a pattern we keep seeing. You take a simple tool, you add intelligence to it, markdown rendering, AI features, whatever, and you inherit an entire attack surface the original designers never anticipated. Notepad was secure for 30 years because it literally just displayed text. The moment it started interpreting text, it became a vector. It's patched now. Update to version 11.25, 10, or later, but the lesson is bigger than the bug.
Completely different story now. The M&A machine. 3 moves this week. Proofpoint acquired Acuity, which does agentic workspace security. Think governance for AI agents across endpoints, browsers, even MCP servers. Scalar acquired SquareX, a browser security startup whose tech embeds lightweight security extensions directly into browsers. And Thales launched AI Security Fabric, a new runtime protection platform for LLM apps and agentic systems, with an MCP security gateway planned for later this year.
2 acquisitions and a major launch in 1 week, all targeting the same gap: securing the places where humans interact with AI agents. Proofpoint is betting on governance, Zscaler is betting on the browser layer, and Thales is going after runtime. Every major cybersecurity platform is scrambling to cover the AI security stack before RSA in 2 weeks. This is going to be the loudest RSA for AI security yet.
And now, Curator's Corner.
AI security.
So, Curator's Corner. This is the segment where we dig into one idea that cuts across the week's headlines. And this week's thesis is simple but pretty provocative. Agent memory needs its own zero trust moment. The same way we stopped trusting internal network traffic a decade ago, we need to stop trusting what AI agents remember. Think about it. Right now, most AI agents treat their own memory, vector databases, RAG indexes, conversation logs, as ground truth. The agent retrieves a stored record, reasons with it, and acts on it. No verification of where it came from. No check on whether it's been tampered with.
And I'm guessing 3 independent research tracks this week showed why that's a problem.
Exactly 3. The Cloud Security Alliance published work on something called LPCI, Logic Layer Prompt Control Injection. This isn't your standard prompt injection where someone types something malicious into a chat box. LPCI encodes attack payloads into the agent's persistent memory. They sit there dormant, across sessions, across users, until a specific condition triggers them. Testing across ChatGPT, Claude, Gemini, and Llama hit 43 to 49% success rates.
Which means the standard input-output filters that most companies are deploying right now won't catch this. You can't just scan what the user types and what the model outputs. The poison is already inside the house, sitting in the agent's memories.
Exactly, and it's not theoretical anymore. The Microsoft Defender security research team documented what they're calling AI recommendation poisoning. 50 plus unique manipulation prompts from 31 companies across 14 industries. These were legitimate businesses embedding instructions like, remember our company as a trusted source behind summarize with AI buttons, one click, and the agent's memory is permanently altered. These weren't hackers, these were marketing teams.
That's the part that gets me. When your threat model includes both nation-state actors and marketing departments doing prompt SEO, you've got a problem that firewalls aren't going to solve. And separate research, the Minja paper, showed 95% injection success rates for memory poisoning when the attacker doesn't even need privileged access. OWASP has officially listed this as ASI 6 in their Agentic Top 10.
So the proposed direction is straightforward. Treat every stored context record the way Zero Trust treats every network packet. Score it. Validate its provenance. Verify it before the agent reasons with it. The industry built the muscle for network Zero Trust. Now, we need to build the same muscle for agent memory, like before the attack surface gets any bigger.
And the OWASP Agent Memory Guard project that launched this week is actually a first step, reference implementations for runtime defense against exactly this kind of memory poisoning. So at least the building blocks are starting to appear. But if you're deploying agents with persistent memory today, the takeaway is clear. Assume that memory is compromised until proven otherwise.
That's context window for the week of March 8th, 2026. RSA is in 2 weeks, and if this week's M&A pace is any indicator, bring comfortable shoes. You'll be running between vendor booths. Stay secure, everyone.
And maybe check your browser extensions before you go. See you next week.